All right, permutations and combinations are used to determine the number of ways that something can occur, and it's used to calculate probability. So let's start with permutation. It's a selection of a group of objects in which order is important. So if the order is important, it's a permutation. A combination is a selection of a group of objects in which order is not important. So if this is just a group of something and we don't care about the order, we're going to say it's combination. If the order is important, it's a permutation. All right, so there's formulas that we use with these. I'm going to write the permutation formula first, and we're always going to have an N and an R. So N is the total, and R is what we want. And the formula for this, it's going to look like this, NPR, where we put the total on the left and what we want on the right, and it's N factorial divided by N minus R factorial. So same thing here, or combination N is total, R is what you want, it's NCR, and this one's N factorial divided by N minus R factorial, and then we're also going to multiply it by R factorial. So these answers will be smaller than these answers. Now, quick difference between permutation and combination. All right, so here, let's say I've got 10 total people and I have 3 prizes. Now, the difference between a permutation and a combination, let's say those 3 prizes were all $100. So no matter which order I pick your name, you're going to get $100. That's a combination because the order is not important. Now, if I were to change this and say that I have 3 prizes again, but this time I only have one 100, I have a $50 bill and then a $20 bill. So this time order is important. I'd rather get $100 than 20. So this would be a permutation. The order is important. I want them to call my name first so I can get more money. So hopefully that kind of shows a quick difference between combination and permutation. This is a group. They're all the same. Order is not important. It's a group that are all the same. This one is, a lot of times if it's going to be a first, second, third place, president, vice president, secretary, something like that, where these are different options. All right, so I showed you these formulas. Honestly, you really shouldn't have to use those formulas. You can just use your calculator. And if you don't have this calculator at home or you don't have one like it, there's a quick video, really, it's only like 2 minutes, I think, where I show you how to do this on the computer. So if you need to, you can look at that. But for now, I'm just going to use this calculator, and I'm going to do 5P5. So I'm going to hit the 5, and then the PRB button right here. And notice the first option has NPR, so hit the number 1, and then hit a 5. So this answer is 120. Way easier than trying to do some work. Now, let me do the one right below it. So I'm going to hit the 5 again, PRB. This time I'm going to hit the number 2, because I want the C. This one has a combination. I'm doing this one below it. And then I'm going to hit a 5. So same numbers, just one's a permutation, one's a combination. Look how different those answers are. This means there's only one way that I can get a group of 5 out of 5 people. Where this, if I rearrange the order of them, there's 120 different ways. All right, so these are just some more to practice. I'm going to put these answers up so you can see them. All right, so here's these different answers. Check if you want to hit pause and test them on your calculator to see if you can do this. You will have these problems on your homework where you just have to type them in. So, all right, let's try a few problems here. There are 10 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? So you have to first figure out, is this a combination or permutation? And that's what your homework is going to be like too. You have to tell me which it's which. So if we look at this one, we have a gold, a silver, and a bronze. This is like first place, this is second place, and this is third. Order is important. So this is a permutation. The order is important. A gold medal is better than a silver medal. So we have N is our total. That's 10 total people in this competition. And R is what I want. I have 3 medals. So we said it's a permutation. You're going to do 10p3. Type that in the calculator. I'll go through this one more time how to do that. You type the 10. You hit the PRB button. Make sure it has a P on there, and then hit the 3. So there's 720 different ways that you could get a first, second, third. All right, this one. 8 people are in a best pie contest. How many ways can blue, red, and green ribbons be awarded? Again, a blue ribbon is different than a red ribbon, is different than a green ribbon. So this time we have N is 8. I want 3 again here. And this is a permutation again, because the order is important. We have different colored ribbons. If I just said 3 people get a ribbon, they all get a blue ribbon, then it would be a combination. So I'm going to do 8p3. Type it in the calculator, and I get 336. Now, some of you might be wondering if this is the same as kind of what we did last time. If the order is important, with this one, you could just have 3 spots, and you could do 8 times 7 times 6. And if you type that in, 8 times 7 times 6, you get the same answer. Same with the one before it. If you did 10 times 9 times 8, you still get 720. So that's another option, but only for permutation. So 10 times 9 times 8, if you wanted to do it that way. Okay? All right, going on. A group of 7 students working on a project needs to choose 2 from their group to present. So 2 people are going to have to get up in front of the class. So here, this is a combination. The order is not important because 2 people have to get in front of the class no matter what. So N is my total. I have a group of 7 kids. And R is what I want. I want to pick 2 to get in front of the class. We said this is a combination, so I'm going to do 7C2. Type that in on the calculator. I've got 7. Hit the PRB button. Make sure you hit the second option this time, and then 2. So there's 21 different ways that you could pick 2 people. So if you just did 7 times 6, notice you get 42. That's not the same thing. So I wanted to point that out. Make sure you use your combination button. Or you could look at the formula from the front. No, I just wrote it quick up here, that formula from the front that I showed you. And then you could just cross things out. So 7 factorial, 7, 6, 5, 4, 3, 2, 1. 7 minus 2 is 5, so I did 5, 4, 3, 2, 1. And I've got that R, that 2 factorial. So then all of these would cancel out. So I'd have 7 times 6 divided by 2 times 1. So 7 times 6 is 42, divided by 2 times 1 is 2, and that's how you get the 21. If you want to do it that way, you don't have to. Okay, take a look at the next one. 5 cousins at a family reunion decide that 3 are going to get in a car and go pick up pizza. So, no family reunions right now. How many ways can they choose 3 people to go? So again, order's not important. This is a combination because the order's not important. Maybe it's important who gets to sit in the front seat, but we're not going to worry about that. So we've got a total of 5 people, and we want 3 to go. So 5C3, type it in the calculator, or the computer if you don't have a calculator, and you get 10. Type it in the calculator, I got 10. All right, Kelly chooses 3 of 15 flavors of ice cream at the grocery store. So she's standing in front of all these ice creams. There's 15 to pick from, so there's a total of 15. And she wants to put 3 in her grocery cart. So it doesn't really matter what order she puts those in, which is what's going to make this a combination. So 15C3 gives us 455 different options. So on your homework, you're going to have to tell me if it's a combination or permutation, and then you're going to have to give me the answer. So there's 2 parts to each one. All right, one more type of problem here. So this is cards. If you look, I have here a sample space of all the cards. So I've got the blank notes on Buzz if you want to look, but here's what all the cards look like. I've got clubs, spades, hearts, diamonds. There's 13 of each of those type of cards. Let's try a problem here. So 5 cards are drawn from a standard deck of cards. So there are 52 total cards in a deck of cards. So I'm going to put this down here. There's 52 total. I want a hand that has 3 clubs. So these are the clubs right here. If you count across, there's 13 clubs. And I want 2 diamonds. So the diamonds are the ones at the bottom. There's also 13 diamonds. Now, this one's a little bit tricky because what this is saying is that I want 3 clubs and 2 diamonds. So just look at the clubs first. How many clubs are there to pick from? There's 13 clubs to pick from. And I want 3 of them. It's a combination because the order is not important that I'm dealt the hands. I can take my cards and rearrange them. I just got some cards out. And I just realized that I said, here, those ones are clubs. These ones are spades. Sorry, guys. All right, so there, I've got 3 clubs. Look, if I rearrange them, it's the same 3 clubs. If I arrange them, it's the same 3 clubs. So order's not important. That's why it's a combination. The word and means to multiply. So diamonds here, I've got 2 diamonds here. Again, the order that I got them doesn't matter. So I want to get 2 of them. I had 13 to pick from. And type this into the calculator. If I do 13, this gives me, ooh, yeah, big numbers here. 286 times 78. Multiply those, and I get 22,308 different options of getting cards. All right, let's try one more. 5 cards are drawn from a standard deck of cards. How many hands consist of 2 face cards? Now remember, the face ones look like this. They have the faces on them. Or, look at this picture. It's real small, but there's 12 face cards. So, 12 face cards. So I want to get, how many did I say? 2 face cards. So I want 2 faces. I don't know what that is right there. Sorry. And an ace. 1 ace. And 2 others. So remember, I want 2 face cards. There's 12 to pick from. I don't care what order I get them. And I want 1 ace. So if I look here, these are the 4 aces right here. So there's 4 aces to pick from, and I just want 1. And now others. So let's see. Remember, I have 52 total. Let me clear this out. I've got 52 total. I'm going to get rid of the face cards because I've already included them. And now I'm going to get rid of the 4 aces. So I've got 36 other cards. So all these cards here in the middle, there's 36 other cards. And I want 2 of those. So when I type it in, I get 66 possible ways to get 2 face cards, 4 ways I can get an ace, and then 630 ways that I could get non-face or non-ace cards. So times 4 times 66. If I multiply these together, I get 166,320 different ways. So these are definitely trickier, but I bet you guys can do it. Do your best. See ya.